discuss with the next topic today, energy. So far I have explained about the term work, where the work is done, when the work is not done, and also the units of work in the CGS and the SI unit. So now today we will come to the term energy. Now as you know that the term work and energy, they are related with each other. That means how they are related is, if you do some work, you spend energy. And the amount of work done depends upon the energy possessed in your body. If you have got more energy, you can able to do more work, more amount of work in more time. If you have less energy, less amount of work. So therefore, since they are related with each other, and therefore when we define energy, energy is defined as the capacity or the ability to do work. Energy is defined as the ability or the capacity to do work. So I'll give you one example. Suppose if you run, while running, you spend your energy present in your body or possessed in your body. And when you run, initially you run very fast, your speed is more or velocity is more, and slowly what will happen, your speed goes on reducing, it becomes less. So, and finally what will happen, after some times your speed will reduce and you will get tired. Okay, before you can run very fast, your velocity is more, but after covering some distance, your speed will go on reducing and you will start getting tired. So how it happens is, initially when you start running, your body possesses more energy and you spend that energy while running. Okay, you spend energy, and when you run, you are using your energy, you are spending your energy, and after some time you get tired. That means whatever the energy which are stored in the body has been utilized to do work, and what work you are doing is that you are running. You are running means you are making some displacement, you are covering some distance. So in order to do some work, the body has to produce some displacement. So here also while running, the body has produced displacement. So the two conditions will come here finally. Okay, one condition is there, that means you can run very fast, and after some time your velocity decreases and you start getting tired, and you finally stop running. You can't run further. Now what happens here? The energy gets wasted. So while doing work, this example indicates or shows that when you do work, either you run or play or move from one place to another, or carry things from one place to another. When you do work, your energy gets wasted, and this energy gets wasted while doing work. So therefore, when we define work, okay, so work is done when, or energy is when the work is done when the force applied on it. And in the same way, when we define energy, energy is defined as the capacity or the ability to do work. So that means while doing work, you will spend your energy, you will lose your energy, and therefore you will get tired, which the example indicates that after some time you get tired. Okay, so that means whatever the energy posed in the body has been lost while running. So therefore energy is defined as the capacity to do work. So more amount of work you can do if you have got more energy. Less amount of work you can do if you have got less energy. So this is how the energy it defines. And the next one is the unit of energy. Since energy and work, they are related with each other, so therefore the units of energy in the CGS and SI system will also be same as that of work. The CGS unit of energy is Earth, and the SI unit of energy is Joule. And the next point is the mechanical energy. So before we come to the mechanical energy, let us come about the conservation of energy. Energy can neither be created nor destroyed. You cannot create energy nor you can destroy it. But that energy can be transformed from one form to another form. That means it can be changed from one form to another. So I will give you an example of one electrical device. Let us consider electric bulb. In the electric bulb will give you light, as well as the bulb gets heated up. Now this electrical and this this bulb, though they give heat and a light, and how they are giving is that the bulb will glow, the bulb gets heated up, the bulb will give light only when there is electric current. So electricity is also considered as energy because they do work. There are different forms of energy, okay, like mechanical energy, chemical energy, light energy, heat energy, geothermal energy, potential energy, kinetic energy. So many different forms of energies are there. Okay, and these forms of energy you cannot create nor you can destroy it, but they can be transferred from one form to another. So example, which I am saying that the example of a bulb. So the bulb, in a bulb, the electrical energy will be converted into light and heat energy, because the bulb will give us light. It will make your house bright during the night only if there is electric current or electricity is there. So this bulb will glow only if there is electricity. So therefore in bulb what happens is that the electrical energy will be converted into light and heat energy. Similarly, in a music, like in a speaker, loudspeaker, the electrical energy will be converted into sound energy. In electrical energy will be converted into heat energy. Likewise, as well in a vehicle also. In a vehicle, the fuel is needed in order to do work. And what are the fuels needed is petrol or diesel. And in this fuel, some energy are stored on it, and this energy is chemical energy. And this chemical energy stored in the fuel will be converted into mechanical energy. Okay, mechanical energy means which comes in the state of motion. So chemical energy stored in the fuel will be converted into mechanical energy. Even in a food also. Okay, in a food, the solar energy. The plant will trap solar energy, okay, they will absorb solar energy, and with the help of solar energy, they will prepare their food, the plants prepare their food, and in the food, chemical energy are stored on it. And this food contains chemical energy, and the chemical energy which we consume or we utilize in the form of food, this chemical energy will be converted again into mechanical energy. So there are various forms of energy, and always the transformation of energy takes place, and the energy can neither be created nor destroyed. So likewise, so the next point will come to the mechanical energy. And now this mechanical energy is the energy possessed by the body due to the work done. Okay, it is the energy possessed by the body due to the work done. So that means when the work is done by the body, the energy possessed in that body is the mechanical energy. Okay, so mechanical energy is the energy possessed by the body due to which the work is done. So when the work is done by the body, then that energy we call it as a mechanical energy. So there are two forms of mechanical energy. One is a kinetic energy, K-I-N-E-T-I-C, kinetic energy, and other one is a potential energy. P-O-T-E-N-T-I-A-L, potential energy. Two forms of mechanical energy are kinetic energy and potential energy. And kinetic energy is the energy possessed by the body when the body is in the state of motion. When the body is in the state of motion, the body will possess kinetic energy. And this kinetic energy, the unit of kinetic energy is joule. The SI unit of kinetic energy is joule, and the CGS unit is earth. And to calculate kinetic energy you can find by the relation half into m into v square. That means, to calculate kinetic energy, you will use the relation half mv square. M is the mass of the body, and v is the velocity of the body. And therefore, this kinetic energy depends upon the two factors. One is the mass of the body, and other one is the velocity of the body. So it depends upon the two. The kinetic energy depends upon two factors. that is mass and the velocity of a body which it possesses. Okay, so this is about the kinetic energy. An example of kinetic energy: a moving vehicle, a flowing water, okay, or a child running on the playground. So anything, any object, when they are in motion, when they are moving, they are considered as the kinetic energy. So there are various kinetic examples of kinetic energy. The running water is there, okay. The moving vehicle is there, moving car, moving vehicle, okay, or even a person running. Okay, all these are examples of the kinetic energy. Next one is the potential energy. Now this potential energy is the energy possessed by the body by virtue of its state or configuration, which means that when there is a change in the shape or size of the body, when there is a change in the shape or size, or when the body is in a state of rest, then the energy is said to be as a potential energy. Okay, like suppose a stored water in a dam. A flowing water possesses kinetic energy, but when the water is stored in a dam to generate electricity, since the water is stored, the water is not doing work. The water is only stored, and that stored water also possesses energy, and that energy is the potential energy. And when that water is allowed to fall or allowed to flow from the dam, then that flowing water will possess again kinetic energy. So therefore, here stored water possesses potential energy, and when that water will flow, potential energy will be converted into kinetic energy. So the stored water in a dam, that is a potential energy. A stretched bow is a potential energy. Okay, then again the compressed spring is also the potential energy. Okay, so then in compressed spring, what will happen? The size of the spring will get small. When you keep on compressed, okay, it becomes smaller and smaller. That means the size will change there, and it remains in the state of rest. So therefore, the compressed spring, the wound up spring, or the stretched bow, or the water which are stored in the dam, all these are the examples of potential energy. So potential energy is the energy possessed by the body due to its position or configuration. That means position is in the state of rest, and configuration, that is the change of shape and size of the body. So now this potential energy are two types again. One is the gravitational potential energy, Gravitational gravitational potential energy, and other one is the elastic potential energy, ELASTS, elastic potential energy. Okay, one is the gravitational potential energy, other one is elastic potential energy. And again, another point is there. To find potential energy, there is a relation to find potential energy. Potential energy equals to mgh. This is the relation to find potential energy. Potential energy can be found by using a relation mgh, which means m is the mass of the body, g is the acceleration due to gravity, and h is the height. Okay, so there are two relations to find kinetic energy and the potential energy. Kinetic energy half mv square, potential energy mgh. And this potential energy depends upon the two factors again. One is the mass of the body, and other one is the height in which the body is raised. One is the mass of the body, and other one is the height in which the body is raised. So this potential energy, it depends. The potential energy also depends on the two factors, same as that of kinetic energy. Now the gravitational potential energy. Now the gravitational potential energy means when a body is raised to a height. Suppose you take a stone, and when you lift a stone and raise it to a height from the ground, you raise the stone up to a height. Okay, and in that case, the energy possessed in the stone which has been raised to a height from the ground, the energy possessed is gravitational potential energy. That is the gravitational potential energy. That means any object, either it can be a stone or anything else. Any object, when they are raised to a height, when they raised, okay, when you lift a stone and keep it on your hand and raise it up. Okay, since the stone is in the state of rest, But even though they are in the state of rest, they possess energy, and that energy is the potential energy, and that potential energy we call it as a gravitational potential energy. Since the stone is raised to a height against the gravity, and when you allow to throw the stone will fall to the ground with an increasing velocity, okay, which we call it as an acceleration due to gravity. Due to acceleration due to gravity, when the stone will fall, the stone will possess acceleration, which we call it as acceleration due to gravity. So therefore, the gravitational potential energy is defined as the potential energy due to raised height or the raised position. So that means any body which possesses gravitational energy when they are in a height, then we call it as a gravitational potential energy. Okay. So the next point is elastic potential energy. Now this elastic potential energy is the energy possessed in a body, okay, when the body is in the stretch or compressed or bent. Either the body is bent, like I gave you the example of a bent bow. Okay, when the bow is bent, potential energy is possessed there, and that potential energy, elastic potential energy. When the spring is compressed, okay, it becomes small. Here also elastic potential energy. Then again, if the spring is stretched, then also here also possess elastic potential energy. So elastic potential energy is the energy possessed in a body when the body is stretched, when the body is compressed, or when the body is bent. So these are the two types of potential energy: gravitational potential energy and elastic potential energy. Okay. So now in the next class we will come to another point, that is transformation of energy. So far I have explained about the term energy, about the term mechanical energy. Two forms of mechanical energy: kinetic and potential energy. Kinetic energy possessed by the body when it is in state of motion. Relation is given half mv square. Factors which depends mass and the velocity of the moving body. Potential energy when the body is in a state of rest or its configuration. Relation to find mass in relation to gravity into height. Again depends on the two factors, mass and the height because the body is raised, and also the two types of potential energy: gravitational potential energy and elastic potential energy. So these things we have discussed related with energy. In the next class we will come to the transformation of